morning. Yes, as Ian said, I now work for Byte. I've had 28 years in the industry. I've been on the research side for 12 years. I've been on the contracting side for 16 years. And now I'm selling machines. But the purpose today is actually to go through today with the masterclass is the cleaning techniques for small bore pipes. We've done the introduction. So one thing is why we need to do, why, the different cleaning methods. So I've gone all the way through from rodding all the way down to high-speed cleaning. The reason why, quite simple really. Removing tree roots, block pipes, fat soils and grease, fogs in pipes need to be removed. We get the pipes that are heavily scaled, so we need to descale them. We get bits where maybe due to poor workmanship or somebody not understanding what's happening. So the bottom left-hand picture, we've got a 32mm, 40mm waste pipe that's been pushed down the lateral connection into the main 100mm pipe. And also, when you're on the emergency response side, we get called out to things like sinks, waste pipes, full, etc. The one bit that I haven't got on here is obviously why do we need to clean? Yes, to restore flow, but also we need to clean pipes to enable pipe rehabilitation. Get the orders in the right place. So the simple ones are, let's go back to the basics, plumbing, rodding and plunging. Typically plastic or steel drain rods, screwed together, clipped together. We've also got contracts out there that use continuous glass fibre rods. They come with a range of tools to go on the ends, but when we're looking at plunging, basically what we're doing really is using the rod with a plunger on, that sends a hydraulic shock wave through the pipe, which will then break up and dislodge the blockage. If you're working internally, then we have these domestic industrial plungers. There's one thing that I've learned 16 years in contracting, 1,000 engineers on the road, is plunging is great if you can see all of the pipe work. Right? If you work in somebody's bathroom, you're working in multi-story blocks where all the pipe work's hidden in false ceilings, that shock wave that when you do the plunging, the shock wave can go along. If you've got a weak joint, that joint can break open, and then you'll end up then discharging. So the engineer thinks he's cleared the blockage, restore flow. All he's actually done is either move the blockage from one floor to another, or we've discharged it over a Starbucks coffee shop. And I got continuously getting phone calls, 16 years at Dyno. So, advantages of it, yeah, it's easy, it's portable, you can work upstream, downstream without potentially any flooding issues. Limitations, we've all had, get the rod stuck. Always if you're going to turn them in an anti-clockwise direction, if not, they unscrew. Depending on how the engineer is using them, there's a high risk of damaging the existing pipe, breaking open joints, breaking joints, push joints that aren't actually connected properly. But that's what we used to do many, many years ago. But we still use it effectively today. We've then got what we call electromechanical machines, first developed back in the 1960s. And I can remember with my days with Jim Zockel, and he was an airline pilot, and he actually brought in the first electromechanical machines in the UK from the States, because he had a blocked pipe in his flat in London. And that started a whole range of Dynarod and small drainage companies. Machines we've got, manufacturers, Rigid, Rhenid, Spartan, so there's various manufacturers out there, different size pipe, machines, etc. We'll do from DN32 up to DN225. The electromechanical, so we actually have an electric motor and the steel shaft. The steel shaft rotates up to probably 500 RPM on the new machine, but generally they're around about 200, 250. The cables themselves come in either sectional, and you clip them together, or they come in lengths of up to 40 meters on a single drum. The operator actually holds, starts spinning up, and then the operator then pushes the steel flexible shaft down through the pipe. On the bigger machines, we have a power feed, so you're not reducing the risk, but also with the power feeds, you're reducing the risk to the engineer, but you're increasing the risk for damaging the pipe, because there's less feel with the power. What are they used for? Descaling pipes, root cutting, blockage removal. It's where, as you can see from the photographs, it's where you can't get in with a jetting machine, probably because you're in the food production area, you're in a multi-storey building where you can't get in with the traditional van packs. They come with various tools. We've got the rod removal, we've got what they call the drop head, which is very useful if you're working on horizontal pipes and dropping into a vertical pipe. Gravity will always drop, the drop head will drop down, so it'll always enable you to go down the stack pipe or the vertical pipe. Spears for cutting through solid blockages, saw cutters for removing tree roots, P-trap blades that will go around small tight bends, and also cutters for using on specifically pipes that are full of fats, oil and greases. Advantages, yeah, very portable, generally no access issues. You can work upstream without causing flooding, breaks up blockages, goes around bends. The key bit really is actually you don't require any, wrong way. Key bit here is that they are mechanical, they just need power supply, they don't need water. If you've got a fully charged system, you can actually operate without worrying about flooding. Limitations of them, low speed, I mean we're talking 250, 300 RPM. It takes time to descale metal pipes. The operator itself has to hold on to the shaft, so there's always a risk. As you're going down the pipe, you're going to hit the blockage, still keep pushing, the steel cable will coil up inside the pipe. It will get to the stage where the resistance against pushing to uncoiling, the cable will then start uncoiling out of the pipe, around the operator's wrist, arm, hand, neck, etc. So high risk of injury, specifically need training. As you can see here, whenever we're using them, we have what we call rough and tough gloves. So it protects the steel cable that's rotating around from burning or wrapping around the engineer's hand. Most of you are aware, and in here we'll do various, would have used high pressure water jetting. Various manufacturers and machine types around. We get trailer-mounted versions, van packs, we get combination units, we get recycling units. It's generally on small bore pipes, and that's DN75 up to DN450. Most contractors will be using either trailer or mainly van packs. Flow rates vary from 8 gallons per minute up to 18 gallon. Pressure ratings vary from 1900 psi up to 4000 psi, and most jetting machines, when supplied new, come with nearly 100 meters of hose on there, but obviously over the time it gets cut back, shortened, etc. There's a performance-wise high pressure and low flow rates to low pressure and high flow rates. So van pack on the road there. We've got, that's what the unit looks like on the cradle that just lies in and fits inside. That's the general blockage clearance nozzle, 4 backward and 1 forward. And that's an engineer machining through jetting through a gully, removing fats, oils and grease. Standard practice really, and everybody thinks that when we're jetting, We're clearing the blockages, the jetting hose goes up the pipe. Actually, we're doing nothing really when we're going up. It's only when the engineer stops and starts pulling back the jetting hose that we actually start clearing the blockages. The force of the jet breaks up and then removes the blockage. Depending on the flow of water, depends on what material we're pulling back to the downstream manhole. Anything that we jet out should be collected in the downstream manhole and then removed, so it's not going to get flushed down the drainage system and create further blockages. We go up, we stop, and when we're coming from going up the pipe to coming back, we need to keep that stationary time with the jetting nozzle stationary needs to be kept to no more than 60 seconds a minute. Whilst that nozzle is not moving, it is actually going to create damage to the hose pipe. If we're looking at removing silt and loose debris, then generally we'll use a 30-degree shallow angle jet head, bomb or plough nozzle, because obviously when we've got silt sits in the bottom of the pipe. The important there really is that because it's loose, we want to jet it back, so we need a high flow rate and low pressure. We have, get the laser button. That's a heavy jet, so because all the debris sits on the bottom, we need to use a heavy jet. As the pressure's coming through and the flow of water, it will try to self-centralise. So with scale loose debris sits in the bottom of the pipe, we need to have a heavy jet that keeps the jetting nozzles down to the pipe invert. Grease, fats, oils. Generally to this, use a 60-degree jetting nozzle, gives us medium thrust, medium impact. A 6-hole jet is for anyone with 6 reverse jets on. Give us optimum coverage. If the operator just pulls the jetting hose back down, all it'll do, it'll take out the bits of fats where the nozzle is in contact with the pipe wall, and you'll get tram lines. As the engineer's doing it, they normally rotate as they're pulling back, rotate the jetting hose backwards and forwards to give us that full coverage. Some of the guys will use spinning jets to clear that, which is a really good finish. Generally, most of the spinning jets will actually have a connector on the front of it, because obviously with it spinning, you get very little thrust, so we normally pull that through the pipe, or they'll use a standard jetting nozzle first to get down to the far end and then change the nozzle over for the spinning one. A hard scale and descaling pipes, and again 80 to 90 degree nozzles, maximum impact but very low thrust, so again we normally have to either use a standard nozzle to get the hose down the pipe, or we winch it through, pull back then slowly to clear the scale. Also with tree roots, we can use a frail jet. So you've got here some chains that are set to the inside of the pipe for removing hard deposits, scale, incrustation, etc. Also, depending on the size of the pump that's on the jetting machine, we can have hydraulic cutters working on the water, using the water pressure. Again here, it's got teeth on both sides, so it will cut out tree roots. Another one here that's for tree roots, and then we've got one down here that is used for grout and concretes with the ceramic carbide tips on. One thing to bear in mind when we're jetting is that we have two codes of practice. We've got the Water Jetting Association relates to using high pressure water jetting machines and the equipment, and we have the WRC Jetting Code of Practice. One thing to bear in mind whenever we're doing anything with high pressure water jetting is, firstly, if we're working in an area where we've got pitch fibre pipes, then they are very susceptible to damaging by the water jetting, and depending on the structural condition of the pipe, going in with high flow rates and high pressures can actually cause a sewer collapse or a pipe to collapse. So because of that, in the WRC Jetting Code of Practice, we have what the 5 levels of structural condition. Obviously, grade 1, and it's the same for pipe rehabilitation when we're doing structural analysis of pipelines. It's exactly the same structural condition codes. 1 is a perfect pipe, grade 2's got minor cracks, grade 3's got fractures and slight deformations. Grade 4 is where we've got badly deformed or multiple fractures, and 5 is collapsed. And the sewer codes normally put that as an X, because X marks the spot where we're going to dig. So you've got to be aware of the different structural conditions. So in the code itself, we've got grades 1 and 2. When we're looking at grades 1 and 2, we've got the pipe material, and we've got the maximum pressures that you can use for jetting. We get to grade 3, grade 4, and grade 5. As you can see, when we start getting to grade 3 and 4, we start limiting the amount of jetting pressure in the pipeline to reduce the risk of damaging that pipe further. If you are an emergency engineer that's just doing day-in blockage clearance work, most of the time when you turn up on site, you won't have a full idea of what pipe material is in the ground. Okay? If we've already been out, we've cleared the blockage, we've done a camera survey, right, we know the structural conditions of the pipeline, then that should be fed back to the engineers who are doing the response to go back, to keep going back to restore flow until you can get the pipe repaired. Right? If it's an emergency guy and they turn up and they don't know, then for areas where we're in areas of clay and concrete pipes, or they don't know, then it's 1900 PSI, 130 bar pressure, right? You try restoring flow at that level. If you're working in areas of brick sewers or pitch fibre, then you need to then drop down to 1500 PSI, okay? It's important, obviously because of this, that as part of the training, the engineers that are doing the jetting are made aware of this, okay? Always go into low, if you're not too sure, go into low pressure, yeah, and clear the blockage. If you can't clear it, then have the conversation with the customer and then start increasing the pressure. One of the areas where the advantages is that high pressure water jetting is very quick and effective on breaking up blockages. Right? If you go for that ultra high pressure machines, you can actually cut out steel pipes, etc., with the technology. Okay. Limitations: requires a good supply of water, especially when you're using van packs. You're limited to how much water you can carry on the vehicle. Hence why you'll see a lot of the jet vacs around with larger tank capacity of water. If used incorrectly, it can cause the pipe to fail or collapse. I know that's in my experience with engineers on the domestic side, very rarely will we use high pressure water jetting in buildings. We're also very careful if we are jetting from an outside manhole back towards the property, especially if they've got a downstairs toilet, because the back pressure from the jetting machine can actually force the blockage out through the toilet and into the downstairs bathroom, which is not good, especially for customer service. Depending where you're jetting and the length and the diameter of the pipe, if you're jetting upstream, when you break the blockage up, the stored water in the system will then come back towards the manhole from where you're working from. And in some cases, the amount of water coming back is probably too great for the outlet of the manhole, therefore you then get a vertical jet of water, sewage coming out, creating a flooding incident. I'm sure later on this morning, Simon will go about the need for the training, and I've seen his presentation. He's got some lovely photographs of hand injuries, etc., relating to it. Like I say, it can cause the pipe to collapse. I have here is I'm not showing who it was and which contractor it was, but they were jetting away, totally unaware that the jetting hose and nozzle had come out of the pipe. and was quite happily jetting the rear garden of the property. I can't remember if that was the one, I think that was the one where on the right-hand side, it was a lovely walled, white walled, painted wall on the cottage. And it was covered in excrement, soil, and everything else. And that was I think that was a 2-day job for the contractors to clean the wall. Like I say, it's very effective, but if you use it in the wrong situation, it can create a lot more damage. Final few slides are relating to high-speed cleaning. Like I said, electromechanical was first introduced back in the 1960s. We're now looking at high-speed cleaning, which was first developed in 2010. Suitable for pipe diameters from 32 mil up to 300. Okay, electromechanical machine rotation is somewhere up to maximum 500 RPM. When we're looking at high-speed cleaning, right, the machines start at 500 RPM, and depending on make and model, will go up to 2,900 RPM. Cable lengths vary depending on pipe diameter, but depending on that, length vary is 16 meters up to 40 meters. Diameter-wise, the shaft is from 6 millimeters up to 18 millimeters. The steel flexible shaft is housed in an outer casing. With traditional electromechanical machines, the engineer is holding on to the rotating shaft. Can you imagine what happened if you held on to the rotating shaft at 2,900 RPM? Right? So these machines come with an outer casing. So the engineer is actually holding on to the outer casing and not onto any rotating parts. Like electromechanical machines, high-speed cleaning is exactly the same. You feed the shaft through the pipe to clean and to restore flow. Very effective at descaling pipes, root cutting, blockage removal, removing fogs, fats, oil and grease. Because of the speed of rotation, right, you can actually use these machines for cutting out failed liners, right, cutting out concrete, use it for reinstating lateral connections post-lining. Give you an example. I've used one of the machines on root cutting, and it was 10 meters of 4-inch pipe, which we couldn't jet. We tried jetting it. We tried nearly everything. The engineers were going to go for an excavate and replace. We brought in one of the early high-speed cleaning machines, and that actually cleared 10 meters of mass tree roots in 45 minutes. Okay, we've had a machine out last week. Look on a job where the contractor cleaned descaled 150 meters of cast iron pipe, 3-inch diameter, in a day using a high-speed machine. So the productivity rates you get from these, because of the way they operate, are superb. I'm hoping this next one's going to work. It said press twice. There we are. So you can see that's about 1,500 RPM, and it's just the scale just gets. Let's try again, shall we? I won't touch the button. So it's sitting there, the engineer's holding the outer shaft that's not rotating. It's turning everything into dust. We have different tools for different jobs, but that is the high speed. So tool-wise, different tools to electromechanical. We have what we call original chains and cyclone chains. They rotate anywhere between, like I said, 500 to 2,900. Any scale in there gets pulverized into a fine dust. Any tree roots get shredded, okay? We've got what we call the spider, the smart spider. Got individual legs on. Got quite a few contractors in the UK are using this to remove fogs from pipes. Also, if you're on the rehabilitation side, you're going to want to put a lining through the pipe. Before you want to line it, you need to clean it and inspect it. If you've got a section of the pipe missing, it's very hard to clean it because the jetting nozzle then comes out the pipe and starts jetting and cleaning the earth from around the pipe. The camera will drop into the hole and you can't get through. What I've got is contractors fastening the CCTV camera to the outer casing, yeah? Using the electromechanical, the high-speed machine at slow speed and pushing it down. The spider legs flip it in and out, right? They will go through the void. They will cross that void and they'll get your camera to the far end. Yeah, it'll clean the pipe and it'll enable you to do the first survey before you do the rehabilitation. Smart cutters, one button. Okay, the smart cutter has grinding panels. Very effective. If you're doing steel welding of pipes, once you've welded the pipe, you've got that internal bead. The smart cutter will remove that steel welded bead within 2 minutes, back to flush, right? Same on plastic pipes, it remove the build, the internal welds as well. Great for any job you really want to do, whether it's descaling, root cutting. The smart cutter generally is the one that will always get you out of the problem area. Specialist tools for opening liners, special tools for removing concrete. There's a whole range of stuff. Because of the speed that they rotate at, it opens up a completely different area and allows us to do totally different blockages and remove like failed liners, concrete, etc., which you can't do with normal pipe cleaning equipment. This is a little video which again demonstrates the ability to use high-speed cleaning to remove failed liners. But we have the special cutting heads. That's on the photograph, the tool on the left-hand side. And it's literally just chomping it through the failed liner. Whoops. It will go through, the harder the material, the better it cuts. But we can easily do 3 to 5 meters an hour, 3 to 5 meters an hour with the high-speed machines. And normally, most contractors don't want to use this tool because if you're going to come and talk to me about using this tool, it normally means that you've got a mess, you've got a problem with the liner. And most people don't want liners to go wrong. The issue normally with lining is you've put that liner in because it's too expensive or it's not, or you can't physically excavate and replace that pipe. So this for pipe rehabilitation, the machines not only allow you to do more, it also gets you out of a problem when it goes wrong. So high speed, portable, no access problems. High-speed machines have a built-in safety clutch as well, which if there's any draw on power, etc., then the machine will switch off before there's any signs of anything coiling up inside the pipe. The operator who's using it is actually holding onto the outer casing that's not rotating. We'll go around bends and multiple bends. We don't need any water. It's great for vertical and horizontal pipes. Same as electrical and mechanical machines. Limitations currently are actually, I think the maximum length of shaft currently is 40 meters. And currently the biggest diameter that the machines go up to by any manufacturer is DN 300. So that really is, we can start off with the simple end, rodding, electromechanical, water jetting, high-speed cleaning, right? I can remember years ago, rodding, electromechanical was the first priority after that. Then we developed water jetting. Water jetting then took over, and a lot of engineers stopped using electromechanical. But as we've gone through, there's the limitations with high pressure water jetting, that actually in small bore pipes, internal pipe work in buildings, we're moving away from the jetting back into the electromechanical. But actually now having the high speed drain, the high speed machines, just opens up the whole market for greater productivity, low risk to the operator. And it's you know, it's, like I said, it's moved things on. It will never be a replacement for, there's never going to be one cleaning method that will do every situation. It's like with everything, a mechanic, we need a drainage engineer needs a toolbox of tools, methods to use. And it only goes wrong, generally when it goes wrong, it's because they've used the wrong method, and they've selected the wrong method, or they used that method incorrectly. I finished.